Uniform accelerated motion. Alright, in this lesson, we're going to do some trickier kinematic equations. Okay, you're going to use the same equations you've been using for more than a unit now, but now you're going to apply them to some where you're actually going to have to read into the question and see what else you can tease out of it to actually get the answer, okay? Because you won't be given much, but you'll actually be given enough to find a solution. You just have to learn about a little bit of the verbiage we use here in physics. So question 1, a stone is thrown vertically upward with an initial velocity of 25.2 meters per second. Calculate the maximum height of the stone. Okay, so here you see we're just given one thing, right? We're given VI equals 25.2 meters per second. Okay, it's vertically upward, so it's going to be a positive value, so that's correct. But of course we know that gravity, which is acceleration, is negative 9.8 meters per second squared. So we know that, but we probably could have figured that out in the last couple lessons as well. Okay, that isn't going to be enough, so let's think about this. A stone is thrown vertically upward. Alright, so here's that stone. Let's say we follow its path, it goes up, and then at some point it's going to be here at some maximum point, right? And then it's going to turn around speed-wise and then land down here where it was thrown from. Let's say somebody just launched it off of the ground, it goes up, it reaches a max height, and then it comes back down. Okay, so what do we know? If we look at this, we know that we're given, there is an initial speed, okay, or velocity, 25.2, and then when it comes back down, this is actually a little side note, when it comes back down, it'll actually hit the ground at the same speed that it left at, just in the opposite direction. We don't need that for this question, but velocity final would be negative 25.2 meters per second. Okay, so you throw a ball up, at some point it starts, acceleration is acting down, so it's getting slower and slower and slower and slower, and so at this point it's what? It's zero, okay? At this point, the velocity is actually going to be zero. So the top of this flight path there, its maximum height, it's going to be zero. So we'll just call that V final as zero, and we're just going to analyze the motion from this point to that point. Okay, so we're starting from down here, we're going up, and this is going to be the displacement. So starting down here and going up here. So if we also know that VF equals 0 meters per second, and we're looking for D, then that should be enough to solve this question. Okay, so look at your equation sheet, look at kinematic equations, find something with VF, VI, A, and D, and you'll find that that equation happens to be VF squared equals VI squared plus 2AD. And so we're going to use that to solve this. We want to do it for D. So go ahead and rearrange that, and you will get D equals VF squared minus VI squared all over 2A. Okay, we have this one, and this one, so we will be able to solve. Okay, so displacement equals, let's put these numbers in there. VF squared is 0 meters per second squared, minus VI squared, which is 25.2 meters per second squared, and that's all over 2 times the gravity, which is negative 9.8 meters per second squared. Okay, so if you plug that into your calculator, actually let's look at this first. This is going to be 0, negative, this positive number, so that's going to be a negative number. This on the bottom is a negative number, so it'll end up being a positive number. Okay, so displacement will be positive, which is right because you start here and you move up. Okay, you're going up. Remember, up is positive, right is positive, so that works. You punch that into your calculator and you're going to get 32.4 meters. Okay, let's do another one. Brett's sandwich is dropped from a height of 32.4 meters above the ground. Calculate the velocity of his sandwich as it hits the ground. Okay, so basically there's a Ziploc bag here, and Brett has a sandwich inside of it, and there's like a little tomato sticking out of the side, and he's got a little piece of lettuce there as well, and like here's his ham, there's a small piece. Okay, so here's the sandwich. It's dropped from a height of 32.4 meters, so it's dropped from here. It's gonna hit the ground at some point and splatter into, actually it probably won't splatter, but the Ziploc bag, he blew it up because he thought it'd be funny, so it's gonna pop when it hits the ground. So if he starts here and he lands down here, that means his displacement is he's going down, so negative 32.4 meters, right? Okay. He drops it, so VI, you know, is 0 meters per second, right? Remember, up is positive, right is positive, so gravity acts down. Gravity is negative 9.8 meters per second squared. So even though we're only told one thing, which is the height of his sandwich, we actually have 3 pieces of information. Okay? So what we want to find is the velocity as it hits the ground. Okay, it's going to speed up, and then smash on the ground. So we know VI, it's 0. We know A, it's negative 9.8 meters per second squared. We know displacement, it's negative 32.4 meters, and we're searching for velocity final. So look at your equation sheet, look at the kinematic equations, and you'll find that the equation we want is, yet again, VF squared equals VI squared plus 2AD. Okay, so same one we used in the last question. And this question is even easier because we don't have to do a formula rearrangement, so we can just plug everything in. Although there will be a little trick with square root at the end. So VF is squared. VF equals the square root, right? If we take the square root of each of these sides, then we'll get VF here, right? So VF is going to equal the square root of everything inside there. Remember when we do a square root that it's plus or minus, okay? So we'll get to that at the end. But VI squared, which is 0 squared, plus 2 times A, which is negative 9.8 meters per second squared, times displacement. What's the displacement? Negative 32.4 meters. Okay, so you plug that into your calculator, and you will get a result of, remember it's a square root, okay? So plus or minus will actually work here, and you should find 25.2 is your answer. Meters per second. Okay, you can check your units here. You've got meters squared over second squared. Just square root that, which gives you meters over second. Great, the units work. Okay, so it starts here, and it goes down, and then it smashes down with a velocity that goes this way. That velocity is pointed down, so the one that we want to use is right here. It's the negative sign. Okay, so final velocity is negative 25.2 meters per second. Question number 3. Denemy jumps vertically upward with an initial velocity of 11 meters per second. Calculate the time she is in the air. Okay, so Denemy jumps. So we've got the ground here, and she's getting ready. She's got her legs, and she's going to jump upward. Here she is. Okay, so she jumps up into the air. Initial velocity of 11 meters per second. Okay, she jumps up, so that value is positive. Again, up positive, right positive. Gravity, as always, acts down. It's negative 9.8 meters per second squared. So jumps up, calculate the time she is in the air. So this is Denemy, and she jumps up, okay, at some point, like let's say that this is her trajectory, and she jumps up to here, okay, and here she is at this point. She's all happy. I don't know what happened to her. She looks a little different, but anyway, she jumps up to here, whoa, and then she'll come back down safely. So at this point, something we know. We need to know something because we only have 2 pieces of information. That's really not enough to solve this. So she jumps up at this point. Remember, trajectory starting here, ending here. You're going slower and slower because gravity's slowing down until you get to this point, and your velocity is 0. All right. So at the peak, at the top of this motion, her velocity is 0. So we have initial, we got final, we've got acceleration, we got everything we need. Okay. So VI equals 11 meters per second. V final is 0. Acceleration equals negative 9.8 meters per second squared. And what are we looking for? The time that she is in the air. So T equals a question mark. All right, so look at your equation sheet, look at the kinematic equations, and find the one that has VI, VF, A, and T. You should find A equals VF minus VI over T. Okay? But we want to rearrange this one for time. We don't want to solve for acceleration. We already know it. So if you rearrange that, you will get time equals VF minus VI all over A. So now it's just a simple matter of plugging the numbers in. So T equals VF, which is 0 meters per second, minus VI, which was her initial 11 meters per second. And we're going to divide all of that by negative 9.8 meters per second squared. Okay, let's look at the units off to the side. The unit's going to be meters per second divided by meters per second squared. Meters per second divided by meters per second squared. Fraction divided by a fraction, which means we're going to multiply one by the reciprocal of the other, which looks like this. Meters cancel. One of these seconds takes out one of these, and you're left with seconds, which is great because time should definitely be in seconds. So negative 11 divided by negative 9.8, that means you're going to end up with a positive number. If you put that into your calculator, you're going to get an answer of 1.1. 1.1 seconds. But let's look at this question again. The enemy jumps vertically upward with initial velocity. Calculate the time she is in the air. Well, at this point, she's just up here. She's just halfway. Okay, she's just halfway. So 1.1 seconds is how long it takes for her to go from here to here. Another 1.1 seconds is the time for her to take to go from here to here. So the total time, I'm just going to give the subscript T tote, equals double this. So she's actually going to be in the air for 2.2 seconds. Okay, so that's one way to do it. Another way to do it would be to recognize, okay, well, she jumps up here at 11 meters a second. At some point, she's at 0, but then she comes back down. And then when she lands, she's coming back down at negative 11 meters per second. Okay, she comes back down at negative 11 meters per second. So you could have used the entire projectile motion that she was in here, up and then back down, had VF as negative 11, and you could have got the complete answer right away. So that would look something like this. T equals VF, which would have been negative 11 meters per second, minus her initial velocity, which was 11 meters per second, and divide all that by negative 9.8 meters per second squared. If you put that into your calculator, you get time equals 2.2 seconds. Okay, so it depends how you look at these problems, right? You could like it and say, okay, I'm going to split it up in half and see what happens here. Or I'm going to look at the whole thing and see what happens. And both of them give you the same answer. Okay, final question. A ball is rolled up a constant slope with an initial velocity of 12.0 meters per second. If the ball's displacement is 0.500 meters up the slope after 3.60 seconds, what is the velocity of the ball at that time? Okay, sounds like a lot is going on. As always, let's draw it. Okay, so here's the slope. It's just a ramp. Okay, somebody built this. It's at the skate park, let's say. And we start with a ball. Here it is. And it's rolled up a constant slope with an initial velocity of 12 meters per second. Okay, so this initial speed, which is going that way, VI, equals 12.0 meters per second. Okay, it rolls up. Okay. And so it starts here. Basically, I'm just trying to draw something in line with that ball right there. And it moves, displacement equals 0.500 meters. Okay, so let's say it moves up to this point. Okay, so the ball ends up there, starts here, ends up there. At this point, 3.60 seconds have happened. So from here to here, the time equals 3.60 seconds. Okay, and we want to find out what is the velocity of the ball at that time. Okay, what is the velocity of the ball at that time? Okay, is gravity acting in this? Sure. But do we need it? Probably not. We'll learn more about slopes later, actually, but gravity is acting up and down. Gravity is acting up and down. As always, right? Gravity goes this way, negative 9.8 meters per second squared. But we're really looking at this thing on an angle, right? We've twisted everything, and we're starting here. We're saying that this displacement is positive, and it keeps rolling up. The time is sort of from here to here. The displacement is from here to here. Everything is on this slope. So let's just look at everything along this slope. So let's not worry about gravity. Let's not look at it. Let's not think about it. Let's see if we can solve it with everything that we have. Time equals 3.60 seconds. Displacement equals 0.500 meters. Velocity initial equals 12.0 meters per second. And we're looking for velocity final. Okay? Yes, of course, gravity is going to slow this thing down, but it's on an angle, and we want to look at everything on that angle, so let's just concern ourselves with everything on this angle, which is these things right here, which is t, d, vi, and vf. So look at your equation sheet and find an equation that has all of these variables, and you'll find this one, which says d equals vf plus vi all over 2 times time. Right? And now we want to rearrange this one and solve it for VF. Okay? So we'll do this one the long way. Multiply each sides by 2. Multiply each side by 2. Alright, so that those ones cancel. And that way you're going to want to get rid of what next? Well, let's get rid of the time next. We'll divide each side by time. Divide this one by time. So those are going to cancel. So what are we looking at so far? We've got 2d over t equals vf plus vi. Okay, we're getting there. We just want vf on the left side. And so when we rewrite that, we'll have vf equals 2d, whoops, not dd, 2d over time minus vi. Okay, let's plug that in there. Let's get velocity final. 2 times displacement, 0.500 meters. Divide that by time, which was 3.60 seconds. And we're going to subtract our initial velocity, which is 12.0 meters per second. Oh, it just fits. Okay, so if you plug that into your calculator, you do 2 times 0.5, which is 1, divided by 3.6, which is going to be a very small number, minus 12. It's going to give us a negative number, okay? It actually gives us negative 11.7 meters per second. So let's look at that and think about this. Negative 11.7. Well, if positive, we said we're only looking at this ramp, we're looking at the slope of this ramp, positive is going up this ramp, then what actually happens is this ball goes up, it goes up, it goes up, it slows down, it gets probably up to about here, and then it starts rolling back down. So by the time if the ball is here after 3.60 seconds, it was already here, but it passes it, slows down, stops, comes back down. At this point, at 3.60 seconds, it's actually going back, it's on its way back down the ramp, and back down the ramp is going to be a negative value, and that negative value is negative 11.7 meters per second. So that does make sense, and that's the answer to this one. All right, thank you.